Okay children, once again, welcome back to the online tutor. In this tutorial, I am going to represent the permutation combination third tutorial. In the previous tutorial, we have discussed about the permutation and also we discussed some theorems under the permutation. So after the second tutorial, I told you the third tutorial we are going to discuss about the combination. So the combination is a little bit different rather than the permutation, but there is a huge relationship between permutation and combination. Okay, let's look at the combination. The combination. In permutation, NPR was the number of ways of arranging any R items selected out of n given items. The number of ways making this selected out of n given items. The number of ways of making this selection, the combination, is the number of ways of selecting R items of n items and is denoted by NCR. So NCR equals factorial n over factorial n minus r into factorial r. What's the definition of the combination? Selecting R items from the n items is known as combination, denoted by NCR. To understand NCR better and its relationship with NPR, we give the following two examples. First example, consider a set of four elements, capital A equal A1, A2, A3, A4. Capital A consisting four elements which are A1, A2, A3, A4. We need to select two elements and form a subset of two elements. The answer of this and the related problem of arranging two out of these four elements is illustrated in the following diagram. You can see the diagram. This is decision tree. So the decision tree first leaf, right? It consists in 6 leaves. The first leaf is A1, A2, A1, A3, A1, A4. The next one A2, A3, A2, A4, A3, A4. So likewise, we had all the combinations. The first part is a combination. And that combination is again derived into another part. So each combination part has two categories. So that category is known as the possible arrangement. A1, A2, the arrangement is A1, A2, A2, A1. A1, A3 is the arrangement is A1, A3, A3, A1. Likewise, we had all arrangements for this combination. The total arrangement is 12. So therefore, the first leaf is indicate the first part is indicate the combination. The second part is indicate the arrangements. So you can see in a decision tree we had both permutation and combination. The total number of permutation, the arrangement is 4p2, it's 12. The number of combination is 4z2, it's 6. Okay, let's look at second example. Example number 2. Now consider 4 elements A, B, C, D with 3 taken at a time. That is the combination of 3 letters taken out of the 4 letters. So now you can see the decision tree. So the first part, it is combination of 4 letters taken 3 at a time. ABC, ABD, AZD, BZD. So basically this is the combination. This is the selecting way of 3 elements. But if you are permutate, if you are arranging these 3 letters in different ways, each one you will have 6 arrangements. So likewise here you will have 6 plus 6 plus 6 into 4, 24. So the total permutation is 24. but actually the combination is 4. The other hand, the combination is 4C3 and the permutation is 4P3. 4P3 is 24, 4C3 it's 4. That is the difference of combination and permutation. Permutation is normally used to select something and arranging it onto a straight line. But the combination is normally used for only select something. Let's look at the connection between permutation and combination. Here you can see the number of combination multiplied by number of ways of one combination could be reset equal to the number of permutation. In other words, we can represent it NCR into factorial R equal NPR. So basically NPR, the permutation is selecting and arranging, but the combination is only selecting. That is the connection between NPR and NCR. Therefore, NPR equal to NCR into factorial R. Okay, now we can discuss an example. Question number 1. A question paper of University of Sri Jayawardenapura has 8 questions with 4 questions in part A and 4 questions in part B. How many ways can a student answer 5 questions? Second one, in how many ways can a student answer 5 questions with at least 2 questions from each part? How can we find it? So this is actually selecting. The selecting means combination, right? 8 questions with 4 questions part A, question part B, another 4. In the part question number 1, the row number 1, the part A, in how many ways can a student answer 5 questions? How many ways? Right. Since the total number of questions is 8 and you have to choose only 5, right? Only 5 questions to the answer. Then the answer is 8C5. Factorial 8, factorial 3, factorial 5. So it's 8 into 7 into 6 into factorial 5. 5, 3, 2, 1. 6. Factorial 5 cancel and the answer is 56. Part B. In how many ways can a student answer 5 questions with at least 2 questions from each part? At least, right? So the part A, part B, part A, part B. Right. So a student has either select 3 questions from part A and 2 questions from part B, or 2 questions from part A and 3 questions from part B. So here he can select 3 questions and 2 questions, or 2 questions in 3 questions. Then the total selection is 4C3 or 4C2 plus again 4C2 4C3. So likewise answer is 2 into 4C3 4C2. So this is the final answer of the part B. 3 questions from part A and 2 questions from part B, or else can select 2 questions from part A and 3 questions from part B. So likewise it's 4C3 4C2 4C2 4C3. Okay, let's move to the next question. So the next question, the question number 2, a bag contains 4 different silver coins and 8 different copper coins. Find the number of selection of 6 coins. How many of these selection contain exactly 2 silver coins? How many of these selection contain at least 2 silver coins? Okay, so what about the first one? Find the number of selection of 6 coins. So we have total 12 coins, right? The 12 coin means we need at least we need 6 coins, then 12C6. So the next one, how many of these selection contain exactly 2 silver coins? Exactly 2 means 4C2 into 8C. So all together 6, no? Then this is 4. What about last part C? How many of these selection contain at least 2 silver coins? So the at least and the exactly mean 2 different scenarios, right? The exactly mean we have only 2, but at least mean it can be 2, 3, 4 likewise, right? Then so I'm just making a table. This is our silver, this is our copper. So the silver mean we had at least 2, then silver can be 2, silver can be 3, silver can be 4, right? If you are select silver as the silver as 2, right, then other one should be 4. If it is 3, then this is 3. If it is 4, this is 2, right? Then this is 4C2 and 8C4, right? Plus here 4C3, 8C3 plus 4Z4, 8C2, right? So this is the at least scenario, right? At least mean it can be through 2, 3, 4 likewise. Okay children, let's move to the third question. There are 10 different marbles to be divided among 2 boys, Ajit and Saman. If Ajit gets 6 marbles and Saman 4 marbles, in how many ways can this be done, right? So we have 10 marbles, right? 10 marbles, right? And Ajit and Saman already here. And the first question, part A, if Ajit gets 6 marbles and Saman 4 marbles, in how many ways can this be done? The number of ways Ajit can get 4 marbles is 10C6, right? And when the Ajit gets 6 marbles, the Saman will automatically get the remaining 4 marbles. Then it's 4C4, no? This is already 1. So the total number of ways of these 10 marbles can be divided into 10Z6 into 1. It's 10C6, right? So this is the answer of the part A. The part B, if either Ajit or Saman gets 6 marbles and the remaining marbles go to the other, how many ways can be done? If either Ajit or Saman gets 6 marbles and the remaining marble go to the other, in how many ways can this be done? Here either Ajit will get 6 marbles or Saman will get 6 marbles, right? When Ajit gets 6 marbles, Saman again automatically gets 4 marbles and vice versa. The number of ways of Ajit gets 6 marbles is 10C6, right? 10C6, then other one is automatically get the 4Z4, right? So the likewise the other way around, again it's 10C6 into 4Z4. Therefore the answer is 2 times 10C6. 2 times 10C6. Right. So this is the question number 3 I selected. Okay children, let's move to the another question. A class of 10 students consisting of 7 boys and 3 girls. In how many different ways can the committee of 4 students can be formed? Students be formed. In how many committees will there be exactly 1 girl? In how many committees will there be at least 1 girl? Okay, so here this is my summary. We have 10 students for the class and for 7 boys, 3 girls. In how many different ways the committee of 4 students can be formed? The committee is actually consisting 4, then its C is 6, 10C4. In how many committee will be there with exactly 1 girl? Exactly 1 girl. Right, so exactly one girl mean you have to select one girl, right? Exactly one girl, C3, 3Z1, and the other will be boys. 7C, we have 7 boys, and you have to select only 3, right? Because 3 and 1 is 4. No? Right. In how many committee will there be at least one girl? At least and exactly mean two different scenarios. I told you the second row number. At least mean we have it can be 1, 2, 3 likewise, right? But the exactly mean it's exactly not can't be changed, right? So exactly one girl mean you have to avoid. So this is selecting for any student, no, any 4 student, no. So I'm going to subtract 10Z4 by selecting only boys, right? Selecting only boy is 7C4, right? Selecting only boy. So selecting only boy is subtracted. Selecting only boy, right? Selecting only boy, right? It's subtracted by the all selection. All selection. So this is the row number 3. Right. Okay, children, let's move to another example. A question paper consisting of 10 questions. A candidate has to answer 7 questions out of the 10 questions. In how many ways can he choose to answer the questions? If he is permutated the answers in any of the 7 questions. Part B, in how many ways can he choose to answer the question if he has to answer the first 3 questions? The last one, in how many ways he choose to answer the questions if he has to answer at least 3 questions out of the first 4 questions. Okay, so the paper consisting 10 questions, right? 10 questions, and the candidate has to answer only 7 questions, right? Only 7 out of these 10 questions. In how many, the part A, in how many ways can he choose to answer the questions if he is permutated answering any of 7 questions? So the any of me, it's 10C7, no? 10Z7. So this number of times he has to select the questions, right? Different selections. So if you want to simplify, so I'll just it's 7 and 3, right? 10, 9, 8, factorial 7, 3, 2, 1, right? So this is 3, right? And 7 also cancel, this is 4. 12, 120. So he has 100, each student has 120 different selections actually. Part B, in how many ways can he choose to answer the questions if he has to answer the first 3 questions? So the first 3 questions is compulsory, right? So he has no other option than C3, 3. Right, the first 3 as C3, C, just no need to write it actually. So the other 7 can be, right, it's vary, right? So other 7 mean 7, he has to select only 4, no? Then answer is 7C4. 7Z4. Okay, so the last row now, last question. In how many ways can he choose to answer the questions if he has to answer at least 3 questions out of the first 4 questions? In how many ways can he choose to answer the questions if he has to answer at least 3 questions out of first 4 questions? So the out of first 4 questions, right? So 1, 2, 3, 4. 1, 2, 3, 4, right? So these 4 questions at least you have to select 3, but some student can be taken all 4 questions, right? So there are 2 different scenarios. So someone can take 3 out of 4, right? And other 4 will be the other 6, right? Or else someone can be select first 4, right? And other 3 out of 6, right? So these 2 scenarios are appeared, right? So the answer will be 4Z4, right? 4Z4 and 6C3.
plus
or else someone can be taken
4C3, right? 4C3, 6C4.
6C4. So these are the addition of the answer, right? So the first 4 questions, someone has to be select only 3 questions, someone has to be select 4 questions. So likewise you have to understand these two cases, right? Okay, so this is my question number 5. Okay children, this is about my third tutorial of the permutation and combination. This is about the combination actually, and I attached some homeworks to be done, so you can try it, right? So I'm also expecting your answers, right? You can send me the answers as well, and also here is the comment section available. You can type any questions that you have occurred when you are doing this. Actually the permutation combination lesson is a little bit different rather than the other pure lessons, right? This is really logical lesson, that is why. And so the next tutorial I will discuss more examples with the combination, right? So this is a briefly idea about the combination. Okay, so thank you very much. So be with us and have a nice day. Goodbye.